In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if any man travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your exceptional support to make this channel a grand success. We are a partner, a family. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition in the world by large. Okay, today I'm going to discuss my lecture number 16, oil and gas production, exploration, production, upstream, midstream refining, petrochemicals, differentiated performance enabling profit optimization, lecture number 16. Before my lecture, I used to read a Quranic verse, Qala Rabbi Shrah li Sadri wa Yassir li Amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi Zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my sayings. Allahumma Rabbi Zidni ilma. O Allah, advance me in my knowledge and true understanding. Thank you very much for your precious time. Now I'm going to read my lecture number 60. Please send me your feedback and comments. I have provided my email address and WhatsApp number last slide of my presentation. Okay, this is my plan. Introductions, oil and gas production. First introduction, facilities processing, reservoir and wellhead, upstream facilities, midstream, refining facilities, petrochemicals, utility system, unconventional, conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. Plan to deliver more than 300 lectures next couple of years. Okay, today I'm going to discuss oil and gas production, upstream oil and gas processing facilities. Today my target to address are physical meters, storage and marine loading. Okay. Key takeaway points. Lecture number 16, facilities process onshore offshore, physical metering, storage and marine unloading. Okay, oil and gas storage, metering and export. The final stage before the oil and gas leaves the platform consists of storage, pumps and pipeline terminal equipments. Okay, first we are going to discuss a physical metering. Physical metering, a partner, authority and customers all calculate invoices, taxes and payments based on the actual product shipped out. Often custody transfer also takes place at this point, which means transfer of responsibility or title from the producer to the customer, shuttle tanker operator or pipeline operators, although some small installations are still operated with a dipstick and a manual records. Larger installations have analysis and metering equipments. So in a terminal, in on-site, still we are using dipstick. To make sure our readings are accurate, a fixed or movable prover a loop for calibration is also installed. The illustration shows a full liquid hydrocarbons or condensate metering system. The analyzer instruments on the, as we have provided here, on the left hand side provide data such as density, viscosity and water content, pressure and temperature. Compensation is also included during the calculation. Okay, furthermore, for liquids, turbines, meters with dual pulse outputs are most common. Alternatives are a positive displacement meters, passive fixed volume upper rotations or stroke, and Corson's mass flow meters. Those instruments cannot cover the full range with sufficient accuracy. Therefore, the metering is split into several runs and the number of runs depends on the flow. Each run implies 1 meter and several instruments to provide the temperature and pressure correction. Open and closed valves allow runs to be selected, and control valves can balance the flow between runs. The instrument and actuators are monitored and controlled by the flow computers. If the interface is not a digital, dual pulse trains are used to allow directions, sensing, and fault finding. To obtain the required accuracy, the meters are calibrated. The most common method is a prover loop. A prover ball moves through the loop, and a calibrated volume is provided between the two detectors. Z phase when a meter is to be calibrated. The four-phase valves open to allow all to flow behind the ball. The number of pulses from its passes on the detector Z to the other end counted after one loops to the four-phase valves turn to the reverse of flow direction and the ball moves back, providing the same volume in reverse, again counting the pulse from the non-reference volume, numbers of the pulses, pressures, and temperature. The flow computer can calculate the meter factors and provide accurate flow measurements using the formulas from industry standard organizations such as the API, MPMS, and ISO 5024. The accuracy is typically plus minus 0.3% of standard volume. Okay, similarly, the gas metering is similar, but instead analyzer will measure hydrocarbon content and energy value. Okay, it will measure mj per cm or BTU, kilocalorie per CFC, as well as a pressure and temperature. The meters are normally orifice meters or ultrasonic meters. Orifice plates with the diameter less than the pipe are mounted in the cassettes. The pressure differential over the orifice plates as well as the pressure and temperature is used in the standard formula such as AGA3 and ISO 5024/5167 to calculate a normalized flow. Different ranges are accommodates with the different size of restrictions. Orifice plates are sensitive to a buildup of residue and affect the edges of the hole. Larger a new installation, therefore prefer ultrasonic gas meters that work by sending a multiple ultrasonic beams across the path and measure the Doppler effect. Okay, in addition, gas metering is less accurate than a liquid, typically a plus minus 1% at mass. There is usually no prover loop. The instrument and orifice plates are calibrated in separate equipment instead. LNG is often metered with mass flow meters that can operate at required low temperatures. A three-run LNG meter scale is shown as in the pictures. If you can see here, at various points in the movement of oil and gas, similar measurements are taken, usually in a more simplified ways. Okay, example of different gas types are flare gas, a fuel gas, and injected gas, where required accuracy is 2 to 5%. Okay, so for my next slide, we are going to discuss a storage tank. Okay, storage tank. On most production sites, oil and gas are piped directly to the refinery or tank terminals. Gas is difficult to store locally, but occasionally underground mines, converters, or the salt depots can be used to store gas. On a platform without a pipeline, oil is stored in onboard storage tanks to be transported by the shuttle tanker. The oil is stored in storage cells around the shafts on the concrete platform and in tanks on the floating joints. On some floaters are separate storage tankers used. Blast handling is very important in both cases to balance the buoyancy when the oil volume varies. For onshore, fixed roof tanks are used for crude. Floating roof for condensate or rock caves are also used for the storage purpose. Okay, furthermore, a special tanks gauging systems such as the level radars, pressure, or floats are used to measure the level in storage tanks, cells, and caves. The level measurement is converted to volume via tank strapping tables depending on the tank geometry and compensated for the temperature to provide a standard volume. Float gauge can also calculate density and so mass can be established. A tank form consists of 10 to 100 tanks of the varying volume for the typical total capacity in the area 1 to 50 million barrels. Storage or shuttle tankers normally store up to 2 weeks of products 1 week for a normal cycles and 1 extra week for delay. For example, a bad weather. This can amount to several million barrels. Okay, accurate records of the volume and histories are kept to document what are received and dispatched for installation that serves multiple production sites, different qualities and product blending must also be handled. Another planning task is forecasting for the future receipts and delivery products. This is for the stock control and warehousing requirements. A tank farms management systems keeps track on all stock movement and logs all transport operation that take place. Okay, from the next slide, we're going to discuss marine transport. Okay, marine loading and transports. Marine loading systems consist of one or more loading arms, jetties, pumps, valves, and metering systems. Tanker loading systems are complex both because of the volume involved and because several loading arms will normally interact with the tanker's blast system to control the loading operations. The tank must be filled in a certain sequence, otherwise the tanker structures might be damaged due to uneven stress. It is the responsibility of the tanker blast systems to signalize data to the loading system and to operate the different valves and monitor the tank on the board or the ship. Thank you very much for your patience, ma'am. This was my last slide. Okay, now we will conclude today's lecture. What we discussed today, first we had a physical metering, then storage tanks and marine loading. Okay, so my next topic will be midstream facilities. Okay, few references. Qatar Petroleum, Oil and Gas, World Energy Outlook, US Geological Survey, US Department of Energy, Schellenberger's Oil Field, International Energy Agency, Wikipedia, Oklahoma, State Oil Affects Sheets North 6, The Story of Oil in Pennsylvania, Air, Liquid Gas Encyclopedia, Natural Gas from the Wellhead to Burner Tip. Okay, together everyone achieve more. Please do not hesitate. Send me your feedback, comments at t.masood.dear@bath.edu. You may send me through WhatsApp. So I have provided my WhatsApp number. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your precious time.